Imagine asking questions of your own files, your notes, your documents, your records, and getting real answers from an AI that never once touches the internet. Nothing uploaded, nothing sent anywhere. The whole thing running on your own machine. That is a fully local, fully private document chatbot. And a couple of years ago, it was a serious engineering project. Now it is a weekend build. I run exactly this over my own notes and documents every day. And I want to walk you through how the pieces fit together, what makes the answers trustworthy, and the honest limits so you go in clear-eyed. Let me first say plainly why you would want this rather than just using a cloud chatbot. The appeal is privacy and ownership. If your documents are sensitive, personal records, business material, anything you would not want sitting on someone else's server. A local setup keeps every word on your machine, and beyond privacy, you get permanence. Cloud tools change, get discontinued, change their pricing. A local setup you control keeps working as long as your computer does. So this is for people who want an AI that knows their stuff without handing their stuff to anyone. That is a real and growing need. Now let me explain the core idea. Because once it clicks, the whole thing makes sense. A language model on its own does not know anything about your private documents. It was trained on public data, not your files. So the trick is not to retrain it on your documents, which would be slow and expensive. The trick is to let it look things up. When you ask a question, the system first finds the most relevant pieces of your documents, then hands those pieces to the model along with your question and asks it to answer using that material. The model does the reasoning and the language, your documents provide the facts. That lookup then answer pattern is the entire architecture. Let me break that into the actual pieces you need, because there are only a few. First, a way to read your documents and chop them into manageable chunks, because you cannot feed whole books to the model at once. Second, a way to turn each chunk into a numeric fingerprint that captures its meaning, so you can search by meaning rather than exact words. Third, a place to store those fingerprints so you can search them fast. And fourth, the language model itself that reads the retrieved chunks and writes the answer. Each of those pieces has a good local option, which is what makes the whole thing private and free to run after your hardware. Let me take them one at a time, starting with chunking, because it matters more than people expect. You take your documents and split them into pieces, maybe a few paragraphs each. How you split them quietly determines how good your answers are. If you chop too small, each piece loses its context and the model gets fragments that do not mean much. If you chop too big, your search gets blurry because each piece covers too many different things. The sweet spot is pieces that each hold one coherent idea with enough surrounding context to stand on their own. Getting chunking right is honestly half the battle, and it is the part most tutorials gloss over. Next, the fingerprints, which have a proper name, embeddings. An embedding model reads a chunk of text and outputs a list of numbers that represents its meaning. The magic is that two chunks about similar topics end up with similar numbers, even if they use completely different words. That is what lets you search by meaning. Ask about your vacation budget, and it can find the chunk that talks about trip spending, even though you never use the word budget in the document. You can run a good embedding model locally, so this whole semantic search step stays on your machine. It is fast and light, far lighter than running the language model itself. Then you need somewhere to keep those fingerprints and search them quickly, which is a vector store. It holds all your embeddings and, when you ask a question, finds the chunks whose fingerprints are closest in meaning to your question. For a personal collection of documents, even a simple local store is plenty fast. You do not need anything heavy. It sits on your disk, it is private, and it returns the most relevant handful of chunks in a blink. This is the retrieval part, the looking up, and it is what turns a generic model into one that knows your specific material. Finally, the language model reads those retrieved chunks and your questions and writes the answer. This is where your local model from earlier in this series comes in. It does not need to be huge because it is not relying on its own memory for the facts. It is reading them from the chunks you handed it. A solid 7 or 8 billion parameter model running locally does this job well. Its task is to read a few relevant pieces of your documents and answer your question using them in plain language, and that is well within reach of a modest local model, so the whole stack runs comfortably on a home GPU. Now the honest part where this breaks, because no one tells you and then you get burned. The system can only answer from what retrieval finds. If the right chunk does not get retrieved, the model never sees it, and it will either say it does not know or, worse, guess. So retrieval misses are the main failure mode. Your question might use words so different from the document that the search does not connect them, or the answer might be spread across many chunks and only some get pulled in. When answers are wrong, it is usually not the model being dumb. It is retrieval handing it the wrong material. Fixing answer quality almost always means fixing retrieval, not swapping the model. Let me give you the practical moves that make the answers trustworthy, because this is what separates a toy from something you actually rely on. First, have the system show you which chunks it used for each answer. When you can see the source, you can verify instantly and you catch the times it guessed. Second, instruct the model explicitly to answer only from the provided material and to say it does not know when the material does not cover the question. That one instruction dramatically cuts down on confident made-up answers. Third, when an answer is wrong, go look at what got retrieved. 9 times out of 10 you will see the problem was that the right chunk never showed up. It is excellent at finding and summarizing specific facts buried in your documents, pulling together what your notes say about a topic, and answering direct questions where the answer exists somewhere in your files. It is weaker at questions that require reasoning across your entire collection at once, or counting things, or anything where the answer is not stated but has to be inferred from many scattered places. So use it as a brilliant search and summarize tool over your own knowledge, not as an oracle that has deeply understood everything you own. Set it up for what it is good at, and it is genuinely transformative for finding things you half remember writing down. Let me give you the concrete fixes for the retrieval misses, because this is where you actually make it good. The first fix is retrieving more chunks. Instead of grabbing just the single closest piece, grab the top several, so even if the perfect chunk is not ranked first, it still makes it into the material the model sees. The second fix is improving how you chunk, since better chunks make better matches. The third, and this one is powerful, is to have the system rephrase your question a couple of ways before searching, casting a wider net so different wordings can connect to the right chunk. Each of these is a small change, and stacking them turns a retrieval system that misses half the time into one that reliably finds what you need. Let me introduce a refinement that noticeably improves quality, called re-ranking. The initial search is fast but a little blunt. It grabs chunks that are roughly relevant. A re-ranking step takes that handful of candidates and uses a smarter, slower model to judge which ones actually answer the question best, then keeps only the top few. So you cast a wide net cheaply, then carefully pick the genuinely best pieces before handing them to the language model. This two-stage approach, fast broad search then careful re-ranking, gets you much better material than search alone, and it runs locally too. It adds a little time per query, but the jump in answer quality is usually worth it, especially over a large document collections. Let me talk about keeping it current, because a real system is not built once and frozen. Your documents change, you add notes, you update files, you remove old ones. So you need a way to keep the searchable index in sync. The clean approach is to watch your documents folder and, when something changes, re-embed just the affected pieces and update the store. That way you do not rebuild everything from scratch every time, you just patch the parts that changed. For a personal setup, even re-indexing the whole thing occasionally is fine if your collection is not huge. The point is to have a habit or an automation that keeps the index matching reality, because a chatbot answering from stale documents quietly gives you wrong answers. Let me address the multimodal angle briefly, because people ask, so far I have talked about text documents, but a lot of what you want to search lives in other forms, scanned pages, images of documents, PDFs that are really pictures. To make those searchable, you first need to extract the text from them, which is its own step using text recognition tools, also runnable locally. Once the text is extracted, it flows into the same chunk, embed, store pipeline as everything else. So the architecture does not change, you just add a front-end step that turns non-text documents into text first. That lets you build one private chatbot over your whole pile of stuff regardless of what format it started in, which is often where the real value is. Let me name the privacy detail that actually makes or breaks the offline promise, because it is easy to get wrong. For this to be genuinely private, every component has to be local. The embedding model, local. The vector store on your disk, the language model, local. If even one piece quietly calls out to a cloud service, your documents are leaving your machine, and the whole point is lost. So when you assemble this, check each piece. Some convenient tools default to a cloud embedding service or a cloud model unless you tell them otherwise. The discipline is to verify that nothing in the chain phones home. Once you have confirmed that, you can genuinely pull the network cable and watch it keep working, which is the test that proves it is truly private. Let me set realistic expectations on scale, because people imagine pointing this at 1,000,000 documents on day one. For a personal collection, hundreds or a few thousand documents. A simple local setup is fast and works beautifully. As you grow into very large collections, the search step needs more careful engineering to stay fast, and the chunking and retrieval choices matter more. But most people massively overestimate how much they have. Your personal notes, your important records, your reference material, that is usually a modest pile that a simple setup handles with ease. Start with what you actually have, get it working well, and only reach for heavier machinery if you genuinely outgrow the simple version. You probably will not for a long time. So to bring it together, here is the build. Read your documents and chunk them thoughtfully. That is half the quality right there. Embed each chunk with a local embedding model so you can search by meaning. Store those in a simple local vector store. When you ask a question, retrieve the most relevant chunks, hand them to a local language model, and instruct it to answer only from that material and cite its sources. Every piece runs on your machine, so the whole thing is private and free after your hardware. And when answers go wrong, look at retrieval first. That is the entire system, and it really is a weekend project now. A private AI that knows your own documents and never phones home is one of the most genuinely useful things you can build with local AI. And breaking down exactly how it works, with the honest limits, is what this channel is for. If that is your thing, subscribe and follow along. Subscribe for more AI builds.